This is a word equation involving indices. We have 1 minus 16 to the power x all over 1 minus 2 to the power x into 1 plus 4 to the power x is equal to 9. At the first glance, one can really be scared, but if we take our time and reason through, we will see that actually the question does not require much of stress. At the numerator there, it is actually a difference of 2 squares. The moment we identify that, then I think 80% of the solution is already there. We all now just need to apply our bring out the difference of squares first to see it clearly, and then we apply the identity of difference of squares, and then we're able to see the way forward. Okay, so we said the numerator is actually a difference of 2 squares. Let us show that. Now, 16 to the power x is the same as, remember 16 is 4 squared. Then power x is 4 to the 2x. This can be written as 4 to the x squared. And 1 can always be written as 1 squared because 1 squared is still 1. We just write it like this so that we can bring out the difference of squares nature at the numerator. Okay, so our numerator then now becomes 1 minus 16 to the x all over 1 minus 2 to the x into 1 plus 4 to the x. We're still working with the left-hand side. We will later on equate to 9 and work. So let's first of all arrange this or reduce this exponential rational expression. Let's first of all reduce it to its simplest form first before completing the equation and solving. All right, so at the numerator, we'll put it in the form of a difference of 2 squares. So in the place of 1, we write 1 square. In the place of 16 to the x, we write 4 to the x squared. All right. Now we can see clearly the numerator is a difference of 2 squares. Remember the identity of difference of 2 squares. Remember that identity. We're going to transform this numerator now using this identity. Okay, so we see it's equal to wherever we see A, we put 1. Wherever we see B, we put 4 to the x. All right, so let's transform it. We're going to have 1 minus 4 to the x into 1 plus 4 to the x. All of that divided by 1 minus 2 to the x into 1 plus 4 to the x. We can see 1 plus 4 to the x already cancels out. So we have 1 minus 4 to the x all over 1 minus 2 to the x. All of that equal to 9. Remember, our equation was equal to 9. So again, now we get to this level here. To solve for x is not very evident. But again, if we look clearly, you see that this numerator, again, is a difference of 2 squares. Because 4 to the x can be written as 2 to the 2x, which is the same as 2 to the x squared. And again, 1 is 1 squared. So this expression, 1 minus 4 to the x all over 1 minus 2 to the x, can be written as 1 square minus 2 to the x squared all over 1 minus 2 to the x, which using the difference of squares identity can be transformed into 1 minus 2 to the x into 1 plus 2 to the x. All of that divided by 1 minus 2 to the x. Remember, we were told everything is equal to 9. Now, 1 minus 2 to the x cancels 1 minus 2 to the x. And so our expression simplifies to we now have 1 plus 2 to the x is equal to 9. All right. So this equation, when reduced using laws of indices and the difference of 2 squares identity, gives us this. Okay, so wonderful. All right, so we have this simpler exponential equation to solve for x. So this is plus 1. We'll carry that way, it will become negative 1. Will become negative 1. And so we'll have 2 to the x will be equal to 8. This is an index expression. Can we change x? Can we change 8 to an index number with the base 2? Yes. 8 is the same as 2 to the power 3. Now we arrive at 2 to the x equals 2 to the power 3. The bases are equal. It means that the powers must also be equal. Hence, the value of x is 3.